Hey guys, it's James. So, in this little tutorial, I want to show you how I'm going to power up and run my PA-18 Super Cub. This is a 1/3 scale that I built from Balsa USA. It came in as a kit. And I'm here on the workbench with my Futaba radio. And I want to show a few things. Now, this is not to say this is the only way of doing it, but this is the way that I decided that I'm going to set up my plane. So, first and foremost, we have a power board. This happens to be a Turnigy I got from Hobby King. It's a mini power board, mini power box ECO. The instructions are just bogus. The translation is not good at all. But luckily, they have some good schematics, and basically, they give you the all the leads, the signal leads to go to your receiver, and channel 7 has a full lead, so it powers the receiver, and then has redundancy of 2 power sources. You could put a LiPo battery in there up to 12 cells, or you could a life battery, or whatever you want. This is unregulated. Whatever you put in, that's what's going to come out. I happen to choose, and what I like with these giant scale, the servos, I went with the high-tech H805BB. That's ball bearing. The giant scale servos, they take a lot of juice, and you can't just set them up as like a regular 40, 60 size airplane. You're going to need some kind of redundancy. So here, in good milliamps as far as storage capacity, I like the nickel hydride batteries. These are 4,200 milliamps a piece, and the same pack is with for my airplane motor, for the motor. This is gonna get the electronics in there to fire up the gas motor. So I actually got one battery for the engine and 2 batteries for the servos and the receiver. This is set up with telemetry. I don't have the system turned on right now. I use the. Oh, I want to say one thing. This is only for demonstration purposes. This lead right here, directly from the BATS share by SmartFly. There's a switch that's in between here. And matter of fact, these are the switches, battery 1 and battery 2. So there's going to be a mechanical switch between those two. But the BATS safe, BATS share, what it does is whatever voltage is higher, it'll draw from that and use that battery, and then when that one gets to the same as equal to that one, they'll draw together. If one happens to fail, you have a backup battery. It's just a good idea to have something with some type of redundancy as far as power that's going to your servos, because again, these things. I mean, that's my hand, and I mean that's the servo, opposed to a little micro servo. I mean, there's a huge, it's a huge difference, right? So, so now this is it. I mean, here's your batteries. You'll have a mechanical switch. You don't need the bat share, but I like to have it in because of its electronics, and just the fact that I have it. It's going into the board. If you didn't have the bat share, the board would just keep on drawing, from both batteries, and if one battery browns out, basically it's going to do the same thing. It'll still have the same. The board's going to still get the power. You could see in the schematics here, the battery goes in together, and then they feed the board. So if one burnt out, then you'd still have another. But this is again another. I don't know. It's just a backup system. That's what I want to say. So, so you have these leads. You could hook the LiPo batteries in, life batteries in, and then you have the regular standard Futaba connections, which is coming off of the batch here, and in the middle is a mechanical switch. Now I'll turn it on, and what I did is I took my load voltmeter here and I stuck it into one of the channels to show you, what we're getting for power. So we'll just click the switch on, and there it is. We got 4.9. The telemetry is coming in at, it's almost 6.49. Oh, there you go, 6.5. Anyway, telemetry up here on the receiver pack is 6.5, and the external pack is coming from here. That's why this little lead is here. This is an external volt wire that you plug into your Futaba receiver, and that's how I'm able to see the voltage from that, and that's going to power my my airplane. I like this board because I have all my channels clear. I have a powered, safe receiver that's getting power, and I have a board that's feeding all the juice is feeding to the servos. It's not going all through the receiver, and that to me is great because it's not overworking the receiver. So let me switch this. I hope that someone took my. Hey, that's my chair. This is my cat. Look at it. Yep. Say hi, Neelix. Well, anyway, he likes my chair. I hope this helps somebody out. And, I was looking for this kind of information on how to power large-scale planes. And there is a lot of information out. I just figured I'd throw out a little bit more information. This might help simplify it for you guys. It's not overly complicated. I would stress to get some type of power board to equally distribute your power to your large-scale servos. But other than that, this is my way of doing it. So, okay, that's for what it's worth. Bye.